Hi, good day and good holy everyone. I am unique number 9, Gerald Lebron, and I am going to discuss to you the limit of a function and its theorems. What is limits of a function? It is a fundamental concept in calculus concerning the behavior of the function near a particular input. It is used to determine the possible location of moving objects as they approach a certain place or location. And the evaluation of particular limit is what underlies the formulation of derivative and the integral of the function. Let's have this illustration. This can be read as the limit of f of x as x approaches c is L, where f of x be the function, c be a constant which the variable x will approach, and the limit denoted by L is the unique real value that f of x will approach as x approaches to c. This is our function. And this one, it will provide direction on what input should be used to determine the change in output as it's moving toward its limits. While this one is the limit as x approaches c. Before we can solve for the limits of the function, we must learn the limit theorems. And here are the following. We have limit of a constant, limit of an identity function, limit of a linear function, limit of the sum and difference of two functions, limit of a product and quotient of two functions, limit of the nth power of a function, and the limit of the nth root of function. Let's discuss one by one. Limit of a constant. The limit of a constant is itself. If a is the constant, then we have this equation. Limit of a as x approaches c equals a. For example, limit of 5 as x approaches to 3 is equal to 5. 2. Limit of 2000 as x approaches to 0 is 2000. And number 3, limit of pi as x approaches to 2 is equal to pi. Number 2, limit of an identity function. The limit of a function f of x equals x as x approaches c is equal to c. That is, limit of x as x approaches c is equal to c, since we are going to substitute c to the variable x. For example, limit of x as x approaches to 10 equals 10. Limit of x as x approaches to 0 is equal to 0. And limit of x as x approaches 1 over 5 is equal to 1 over 5. If what's our limit, then we will substitute it to our variable. Number 3 is the limit of a linear function. The limit of a linear function f of x is equal to mx plus b, where m and b are any constant. We say that limit mx plus b as x approaches to c is equal to mc plus b, since we are going to substitute c to the variable b. For example, we have limit 5x plus 4 as x approaches 6 equals 5, and we will substitute 6 to the value of x, plus 4 equals 30 plus 4, then it yields us 34. Another example, limit of 10x minus 5 as x approaches 0 equals 10 times 0 minus 5 equals negative 5. So, important to note here is that we are going to substitute our input to the variable, then simplify. Number 4. The limit of the sum and difference of two functions. The limit of the sum or difference of two functions is simply the sum or difference of the limits of the individual functions. Let me say, for example, limit f of x as x approaches c equals L, and limit g of x as x approaches c equals m. So we have this formula. Limit of f of x plus or minus g of x as x approaches c equals L plus or minus m. For example, if our limit f of x as x approaches c is 7 and limit g of x as x approaches c is 4, if we are going to get the sum, then we have limit f of x plus g of x as x approaches c equals the limit 7 plus 4 equals 11. If we're going to take the difference, then we will have 7 minus 4 equals 3. Number 5 is the limit of a product and quotient of two functions. The limit of the product or quotient of two functions is simply the product or quotient of the limits of the individual functions. If limit of x, f of x as x approaches c equals L, and limit of g of x as x approaches c is equal to m, then we have this formula. Limit the product of f of x and g of x as x approaches c equals L times m. And if we get the quotient, we have this formula. Limit f of x over g of x as x approaches c equals L over m. For example, if our limit f of x as x approaches c equals 8 and our limit g of x as x approaches c equals 1/4, if we are going to get the product, we will have this formula and substitute the value of f of x times the value of limit of g of x as x approaches c. So we have 8 times 1/4, and simplify. We have 8 over 4 and gives us 2. If we will get the quotient, we have this formula, limit f of x over g of x as x approaches c, then we are going to substitute the value of limit of f of x, which is 8, over 1 over 4. Then let's multiply by its reciprocal, 8 times 4 over 1, and it will give us 32. Number 6 is the limit of the nth power of a function. The limit of a function with power n, where n is any integer, is simply the limit of a function raised to the power n. In symbols, we have limit f of x raised to the power of n as x approaches c is equal to L raised to n. For example, limit the quantity of 9x minus 7 raised to 2 as x approaches 6 equals, what we do here is we substitute 6 to x. So 9 times 6 minus 7 raised to 2 equals, 9 times 6 is 54, minus 7 is 47. Then we will raise it to square. Then our final answer is 2209. And the last one is the limit of the nth root of function. Here, the limit of the nth root of a function is simply the nth root of limit of the function, provided that if n is even, the value inside the radical sign should be greater than 0. So in symbols, we have limit nth root of f of x as x approaches c is equal to nth root of L, where L is greater than 0 if n is even, for us to have that limit. For example, limit 4th root of 3x plus 7 as x approaches 3 equals, so we are going to substitute 3 to x. So we have 4th root of 3 times 3 plus 7 equals 4th root of 9 plus 7. If we are going to simplify further, we have 4th root of 16, and it will give us a final answer of 2. Another example. What if we have limit 4th root of 3x minus 4 as x approaches to negative 3? Then we are going to substitute negative 3 to x. That's why we have 4th root of 3 times negative 3 minus 4 equals 4th root of negative 9 minus 4. Then if we will further simplify, we have 4th root of negative 13, where our L here is negative 13, which is less than 0 and not greater than 0. That's why our limit 4th root of 3x minus 4 as x approaches negative 3 does not exist, or we will simply write DNA. We have techniques in solving limits of a function. So if, for example, we have this limit x squared plus 3x minus 6 over 2x minus 5 as x approaches negative 3. First thing we are going to do is we will do the substitution. We will substitute the value negative 3 to the x's. So we have negative 3 raised to 2 plus 3 times negative 3 minus 6 over 2 times negative 3 minus 5. So we will further simplify. We have 9 minus 9 minus 6 over negative 6 minus 5 equals 9 minus 15 over negative 6 minus 5. So we have negative 6 over negative 11, or let's divide both the negative sign and it will give us 6 over 11. So by simply substitution or substituting the value of negative 3 to all the x, we get the limit of 6 over 11. Therefore, our limit here exists. So that's the first technique. But in this case, even though we substituted the value of x to our function, we get 0 over 0. So here we must take note. If the numerator and denominator will result to 0, then it is undefined, or in mathematics it is indeterminate. But if the result is the numerator is a non-zero while the denominator is 0, then that could not be possible. It's undefined. But in our case right now, as our denominator is 0 and our numerator is 0, then it's indeterminate. This means that the limit may or may not exist. So what we are going to do next? We will do factoring. Let's try factoring if maybe we can get a solution to it. Like this one. Limit x squared minus x over x squared minus 1 as x approaches to 1. So our x squared minus x, we let's take out x, then x minus 1 will be left inside, over x squared minus 1 is a perfect square, so we have x plus 1 times x minus 1 if we are going to factor it out. Then let's do a cancellation if ever there is a common term in the numerator and in the denominator. And in our example, there is common, then we cancel it out, leaving us limit x over x plus 1 as x approaches to 1. Then we are going to substitute again the value of 1 to the x. So we have 1 over 1 plus 1 equals 1/2. Therefore, in this problem, the limit exists. So in substitution, we have this result 0 over 0, but when we factor out, we get the answer. So limit exists. Another technique, if we have this kind of problem, limit of x minus 16 over square root of x minus 4 as x approaches 16. So we will have the substitution. Then it still give us the answer 0 over 0, where tells us that the limit may or may not exist. But here, instead of factoring, we cannot factor it out, but we will use a multiplication by its conjugate. So here is the example. So conjugate is we are going to multiply. We will use the term which has a radical sign, which is the square root of x minus 4. Then we will change, or vice versa, the operator. If this in this case we have square root of x minus 4, then its conjugate is square root of x plus 4. Then we will multiply that conjugate to the numerator and the denominator. So we have this limit x minus 16 over square root of x minus 4 as x approaches 16 times square root of x plus 4 over square root of x plus 4. Then we are going to simplify. So we just simply factor them. Then in the denominator, this is the trick here, because if we multiply it by its conjugate, then the root of the radical will be eliminated, so it will give us this result. So in the numerator, we still factor this, and in the denominator, it gives us the result of x minus 16. Then we will cancel the common term, and it will leave us an answer square root of x plus 4 as x approaches 16. Then we are going to substitute 16 to x. So square root of 16 plus 4 equals 4 plus 4 equals 8. Therefore, in this problem, our limit exists through multiplying by its conjugate. Now, we are going to illustrate limit of a function using table of values. For example, limit of 3 of x. For example, limit of 3x plus 1 as x approaches to 2 equals 7. We are going to make a number line. Our input here is 2, right? So, from left approaching to 2 and from right approaching to 2. So, from left we are going to start from 0 going to 2, and from the right we are going to start from 4 going to 2. So we have this table from 0 to 2. As we will substitute once we have this value 0 in our x, if we will substitute it to 3x plus 1, our y or f of x is 1. If our x is 0.5, our f of x become 2.5. If our x is 1, then our f of x is 4. If our x is 1.9, our f of x is 6.7. While from the right, 4 to 2. If our x is 4, our f of x is 13. If our x is 3.5, our f of x is 11.5. If our x is 2.1, our f of x is 7.3. If our x is 2.01, our f of x is 7.03. So you notice here that from 0 going to 2, we are not using the exact 2. And from the right, starting from 4 going to 2, we did not use the complete or the perfect number 2, but we only end up in 2.01. And from left 0 to 2, we end up 1.9 or something, 1.999, as long as it's not the 2 or the exact 2. So we get still the final answer of 6.7 and 7.03, which if we are going to round it off, it will still give us the answer of 7. That's why our limit 3x plus 1 as x approaches to 2 is equal to 7 is probably and truly right. So we are going to graph this. Our limit 3x plus 1 as x approaches to 2 equals 7. So its graph looks like this one. It's a straight line. Let's now move to the real-life application of limits. We know limits exist everywhere. And in all we do, there are always limits. From a time to lay down, as the sun rises, then a time to rise. There is a limit in the food we intake. We eat and then we get full. Then there is a limit in speed as we are going to commute. So there is a limit in speed. Even in commuting, the vehicle has its capacity. Like this one, it's overloaded. There is a limit in the use of promos and internets in our cellular phones. A limit in the use of promos and internets. A work in a day. Then, as the day ends, we are going to go home and a time to rest. Therefore, limit exists everywhere, and in all we do, there are always limits, and it is applicable in our day-to-day activity. So that's all for my report. Thank you for watching and thank you for listening.